Okay, let's take a classic 3, 4, 5 triangle and call this theta. And let's go through some definitions. So we first know that sine theta is equal to opposite over hypotenuse. Therefore, sine theta is equal to 3 over 5. We have a new definition, cosecant theta, which from your formula sheet is cosine theta, equals the flip of sine. So if sine is opposite over hypotenuse, cosecant is hypotenuse over opposite, which would give me a cosecant ratio of the flip of sine, 5 over 3. Then we know cosine theta is equal to adjacent over hypotenuse, which would therefore, cosine theta would be 4 over 5. Then we have a new trig ratio, secant theta. And that's the flip of cosine, so that's hypotenuse over adjacent. Therefore, secant theta would equal the flip of cosine, 5 over 4. Now keep in mind in the notes I've done it a little bit differently as well. I've given the definition of secant being 1 over cosine, substituting cosine in and flipping and multiplying and getting the same answer. Be very comfortable using both definitions. I'm going to shrink this up a tad. Excuse me. I'm going to shrink this up a tad so I can continue writing off to the right 2 more definitions. So then we have tan theta. Tan theta is equal to opposite over adjacent. Therefore, tan theta would equal 3 over 4. And our new definition, cotan theta, which is the flip of tan theta, which is adjacent over opposite, which therefore cotan theta would equal adjacent 4 over 3, the flip of tan. So remember, if it's got a t, it's the flip. If it's got a s first, it's the flip of the cosine. If it's got a c first, it's the flip of the sine. So we can kind of work with those opposite letters there. Now, a whole bunch more little examples down below. So, what is the sine of 25 degrees? Well, you better be in degree mode, and that answer is 0.42. Sine of 25 in degrees, 25 sine. Great. So, what about something like cosine of 180? Well, cosine of 180, if we type it into the calculator, is -1. Soon we'll be able to do that algebraically. What if I say CSC theta, CSC 140? CSC 140. What's that equal to? Well, I know that CSC theta is just equal to 1 over sine theta from our formula sheet. Therefore, it's 1 over sine of 140. And 1 divided by sine of 140 is equal to 1.56. I'm going to be circling my answers on the page just so we get more comfortable with what our answers are compared to our formulas, which I usually box out. So there's all types of examples on that page. Feel free to go through them slowly, but I'll just do a couple more. What is the cosine of pi over 3? So remember the last one I didn't put 180, but I should have, 180 degrees. Well, this is a radian, so make sure that your calculator is in radian measure. And what is the cosine of pi over 3? Well, it's simply 1 over 2. You can do that through special triangles. You can do that with the graphing calculator. Let's do another example. Secant theta, secant of 3 over 5. Well, secant of 3 over 5, I know off to the right, secant theta is equal to 1 over cos theta. So it's simply just 1 over cosine of that. 3 over 5. Not secant, it's not cos of 5 over 3. Some people think that you flip the angle. You don't flip the angle, you flip the ratio. And I know that the cosine, 1 divided by the cosine of 3 over 5 is simply 1.21. Keep in mind, these answers are fractions of side length. So if you don't understand what 1.12 means, draw a triangle, write down the ratio, label the triangle, and have you understand it a little bit better. Let's try that. So if I put theta, I know that secant is the, by definition from above, secant is hypotenuse over adjacent, so that's just 1.21. Over the adjacent, every number is over 1, so over an adjacent of 1. Now that is not the identical triangle above, but that is the simplified ratio of that triangle. So just down at the bottom, I'm just going to do one example. I'm going to do the one off to the right. So we're going to do cosine theta equals 3 over 5. Remember, we find theta by doing cos inverse of 3/5. And remember, we get theta to equal 0.93. So remembering how we do the inverse calculation. Remember, that was in radians. I converted my calculator into radians because it said in radians, and that theta is an angle in radians. Feel free to convert it into degrees if you like. There's a whole bunch of other examples. For example, if we have cotan, we have to flip it and use tan because we can only use tan on our calculator. So be really careful with the trig identities, cosecant, secant, and tangent. We have to convert them, cosecant, secant, and cotan. We have to convert them into sine, cosine, or tangent by flipping their ratios and then doing the inverse calculation like I just have with respect to one of the 3 primaries that we started working with in grade 10. All right, so again, lots of the times I'm just going to be using the actual notes and drawing on them specifically. So let's take our A, S, T, C graph, A, S, T, C graph, and find out what that all means. Well, A means all sine, cos, and tan are positive. S means only sine is positive. T means only tan is positive. C means only cos is positive. We have a mnemonic device. All students take calculus. So usually it's going to be easiest just to remember ASTC and remember what's positive or what's negative, because lots of the times we get information and then we forget to do parts of things because we forget the foundations. So in the above examples, let's look in the first quadrant. I have a positive x value, a positive y value, and a positive hypotenuse. Now the hypotenuse is always positive because if I circle above and I do Pythagoras' theorem, if I square root the last step, I always get a positive. So the hypotenuse is always positive. And again, in the first quadrant, if I look at all my ratios, all sine, cos, and tan are all positive. Now if I go into the quadrant on the left, in quadrant 2, I have a negative x value, a positive y value. Again, if I do Pythagoras and I square root the last step, I always get a hypotenuse. The hypotenuse is always positive. And then if I label what sine, cos, and tangent are and all their ratios based on SOHCAHTOA, and then I do that again with Pythagoras in the third quadrant and the fourth quadrant, and label what sine, cos, and tangent are and all the ratios and divide by negatives appropriately, I get what they all are. Now that's a lot of work and a lot of things to remember. So instead, we're just going to remember ASTC. All students take calculus. If you get a ratio sine is positive, 2 triangles where sine's positive. If you get a ratio where cosine is negative, 2 triangles where sine's negative. If you get a triangle where sine's positive and cosine's negative, we need to find out where that triangle goes. ASTC review from grade 11. Okay, a little bit more notes, and again I have the notes up in front. So where did these special triangles down below, come from? Down below come from? Well, let's start in the top left corner. If I take a square with side lengths of 1 and I cut it in half, well, that means that my angle will still be 90 and 45 and 45. And then if I do Pythagoras with 1 and 1, I get my final side to be root 2. Well, notice that's our special triangle. An angle with two angles of 45, one angle of 90, and then their appropriate side lengths, 1, 1, and root 2. Lots of the times it's easier to think through the process of where it came from rather than just strictly blindly memorize. Remember, pi over 4 in the special triangle is 45 because 180 divided by 4 is 45. Now off to the right, let's take an equilateral triangle and let's cut it in half. Well, if my equilateral triangle started off with side lengths of 2, my side lengths are now 2 and 1. And if my initial angle was 60 from before, and I half my other angle of 60, I get 30. And if I do Pythagoras backwards with 2 and 1, I get root 3, which is our special triangle with an angle of 30, 60, and the appropriate side lengths. And a big remember off to the right, 60 is bigger than 30. Root 3 is bigger than 1. 60 must open up. 60 must open up to the root 3 and vice versa. Then just some examples down below of SOHCAHTOA and all of the sine, cosine, tangent ratios for each of the angles of the special triangles. We're going to be using these special triangles all the time, and remember they are a review from grade 11. Okay, let's take a potential question. Sine of pi over 6 is equal to question mark. Well, I'm going to draw an ASTC graph like I always have. I'm always going to mark 0. I'm always going to mark pi. I'm always going to change pi to be a denominator that I'm working with. I'm going to break up this section into 6 sections in my head and decide 1, 2, 3, 4, 5, 6. 1 pi over 6 falls in the first quadrant, barely above the x-axis, and I'm going to put my reference angle of pi over 6. Then I'm going to draw my triangle. Now, I'm going to label the triangle according to special triangles. So we just went over special triangles. We should have them memorized by now, at least in degrees. Now, sometimes I convert that angle, and I know pi over 6, 180 divided by 6, is 30 degrees. And sometimes that helps me label my special triangle. And 1 is opposite of the 30. We have a hypotenuse of 2, and we have an adjacent of root 3. Therefore, above, sine of pi over 6 would be the opposite over the hypotenuse of that triangle, 1 over 2. Circle your answer. Make sure you type sine of pi over 6 in radian mode into your calculator and make sure it gives you 1/2, and you can check your answer. Now let's take the sine of 5 pi over 6. And ask ourselves, what's that equal to? Well, again, I'm going to draw an ASTC graph. And I'm going to mark 0, and I'm going to mark pi, and I'm going to change pi to be a denominator that you're working with. And I hope by this time I sound like a broken record. And I am just really trying to inform how important it is to do some of these basics, because so many times the questions get harder, and if we aren't doing the basics every single time, we'll forget. So 5 pi over 6. So there's 6 pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. We're in the second quadrant, up in this direction, with the same pi over 6 reference angle. Make my triangle. Now I'm going to label the triangle according to special triangles. So again, that's 30 degrees from the last question, with an opposite of 1, hypotenuse of 2, and an adjacent of root 3. And working above, my definition of sine is opposite over adjacent, hypotenuse, and I'm going to quickly ASTC my graph. So I knew in the last question, again I'm going to ASTC my graph in the last question, I knew that they were all positive, so we were positive there. Now I'm in the S quadrant, so where sine is positive again. I'm actually going to say positive in the answer this time, just to reaffirm that I thought through that process. And again, it's 1 over 2. Interesting. Again, I can type that in the calculator, radian mode, sine of pi over 6, and I get a half. Notice the answer is the same. Cool. Okay, what if we do sine of 7 pi over 6 and ask ourselves what's that equal to? No need for the question mark. So again, I'm going to draw an ASTC graph, and I'm going to mark 0, and I'm going to mark pi. Again, my ASTC graph. And 7 pi over 6, well again, I'm going to change pi to be a denominator that I'm working with and multiply the top also by 6. And where would 7 pi over 6 be? Well, we've got 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. So it's going to be down here. And again, from before, we can talk about how we found the reference angle, but please feel free to watch the notes. Pi over 6, make my triangle, label the triangle according to special triangles with an opposite of 1, a hypotenuse of 2, and a adjacent of root 3, and looking above, sine of 7 pi over 6 in the t quadrant will equal negative. And the ratio is 1 over 2 again. Feel free to check that on the graphing calculator in radian mode. So notice, before my answer was positive when I had a reference angle of pi over 6 because I was in the A and the S quadrant. Now I have a negative because I'm in the t quadrant and sine is negative. Feel free to further look in your notes and see that sine of 11 pi over 6 where that falls, and that the ratio is also negative. So notice anytime we have a sine of a pi over 6 reference angle, no matter what the standard position is, that fraction is always 1/2 and positive or negative depending on the location. Okay, a second ago we looked at the sine ratio. Now we're going to look at different ratios like cosine. So cosine of pi over 3 and ask ourselves what that equal to. Excuse me, in the notes, cosine of pi over 6 and ask ourselves what that's equal to. So again, I'm going to draw an ASTC graph. And cosine of pi over 6 will again mark 0 and mark pi and change pi to be a denominator that you're working with, and know that pi over 6 is in this quadrant with a reference angle of pi over 6. And we can draw our special triangle and we can label. So remember, pi over 6 was 30 degrees. 180 divided by 6 is 30 degrees. So we have an opposite of 1, a hypotenuse of 2, and an adjacent of root 3. And above, I know that cosine in the A quadrant is positive ASTC. I should be doing that every time. Cosine is positive, and the definition of cosine is adjacent root 3 divided by the hypotenuse 2, and that is our answer. Feel free to check the answer on the graphing calculator. Cosine of pi over 6, make sure you are in radian mode. And then you're obviously going to get a decimal, and then you'll obviously have to type root 3 over 2 in the calculator and make sure that that's true. So what about the sine of pi over 3? Okay, well, we've got our ASTC graph. We're going to mark 0 and pi and change pi to be a denominator that we're working with. And pi over 3 would just be a little bit steeper than pi over 6 was, because if I change it into 6 parts, 1, 2, 3, 4, 5, 6, but if I change it into 3 parts, 1, 2, 3. So I have my reference angle of pi over 3. I can make my special triangle. Now remember, pi divided by 3 is 60 degrees. And opposite of the 60 is the root 3. We have an adjacent of 1 and a hypotenuse of 2. So looking above, our answer in the ASTC realm will be positive, and the definition of sine is opposite root 3 over hypotenuse 2. And again, feel free to check that on the graphing calculator. So let's do one more example from this page. Let's go for cosine, the bottom left. Cosine 5 pi over 6 equals what? So again, let's draw an ASTC graph. ASTC. Let's mark 0 and pi and change pi to be a denominator that I'm working with. And where would 5 pi over 6 be? Well, 6 pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. We're in the second quadrant going up this direction. I don't have to be perfect. pi over 6 is our reference angle. Remember, do the first section, learn how to add and subtract in radians, figure out what these reference angles are very fast. If this angle is 5 pi over 6, then we have a reference angle of pi over 6. And if we label that according to special triangles, directly above, we have an opposite of 1, a hypotenuse of root 3, and an adjacent of root 3 and a hypotenuse of 2. Therefore, looking above, I'm in the S quadrant, therefore cosine is negative. And I think about that process first. I think, which quadrant am I in? Is sine, cos, or tan positive or negative? And I do that first. I write down if it's positive or negative first. Then I state what the ratio is. So cosine is adjacent over hypotenuse, so root 3 over 2. Circle my answer. Again, feel free to check that in the graphing calculator. Take a look at all the other examples in the notes, worked out in exactly the same order. ASTC, special triangles, 0, pi, change pi to be a denominator you're working with, figure out what your reference angle is, label or answer the question based on SOHCAHTOA and ASTC. Okay, so before we were looking at expressions, and now we're going to be looking at simple equations. So sine theta is equal to a half. Well, what does that mean? Well, I'm going to start by drawing an ASTC graph, which I do most of the time. And as you can see in the notes, I have all the English instructions, so I'm just going to be reading those. But if I draw my ASTC graph, and I know that sine is positive, that means I'm going to put two triangles where sine is positive in the A and the S quadrant. Then my definition of sine theta, we have an opposite of 1 and a hypotenuse of 2. Again, an opposite of 1 and a hypotenuse of 2, which means that from special triangles, if I have an opposite of 1 and a hypotenuse of 2, that means that my special triangle has an adjacent of root 3 and a reference angle in radians of pi divided by 6. So I can put that, excuse me, I can put that angle in both of my reference angle locations, pi over 6 and again pi over 6. And remember, from the beginning we all have to put our arrows in. And so this is a review from grade 11, so we're not going to spend too much time on it. We find our reference angles, and then we put our arrows in. That arrow and that arrow. The arrows from the positive axis to the terminal arm. So my first angle, theta, is equal to pi over 6. And my second angle, theta, is equal to, well, I'm going to mark 0 and pi and change pi to be a denominator that I'm working with. 6 pi over 6, excuse me. And then my other theta will just be pi over 6 short of 6 pi over 6. So I'm not going to do the subtraction again. Please look at your notes and the video from previous sections. But 6 pi over 6 minus pi over 6 is simply 5 pi over 6. And those are going to be both of our answers. And feel free to check your answer by signing them and making sure they're both equal to 1/2, which they are. Just like the question said in the first place, sine theta is equal to 1/2. We found the theta that makes sine theta equal to 1/2, making sure that we check our answer. So we'll review the English instructions. Two triangles where sine's positive. Label the triangles according to special triangles in SOHCAHTOA. Label the reference angle according to special triangles. Draw an arrow from the principal axis to the first terminal arm. Draw an arrow from the principal axis to the second terminal arm, etc. And then figure out what those arrows are worth. So now we're going to take a look at another example, very similar, but we're going to answer it with a general solution. Okay, so still on the same page. We're at the bottom of the page now. We're going to cos x equals -1 over root 2. Well, again, let's start by drawing an ASTC graph. And this time we're going to put two triangles where cosine is negative. So cosine is negative in the S quadrant and in the t quadrant. And now I'm going to label the triangle according to special triangles. So cosine is adjacent over hypotenuse. We have an adjacent of 1 and a hypotenuse of root 2. Notice the 1 acts for both triangles. And then I'm going to draw the special triangle off to the right in the same orientation and label as best as I possibly can, which means that I'm the special triangle with an other side of 1 and a reference angle of pi over 4. So I can put pi over 4 in both locations of the angle. Then I'm going to draw my arrows from the principal axis to the terminal arm, and I'm going to figure out what those arrows are worth, adding and subtracting fractions. Again, feel free to go back to 4.1 and figure out how this all works, but I'm going to mark 0, I'm going to mark pi, I'm going to change pi to be 4 pi over 4. And then I know that my theta is just simply equal to 4 pi over 4 minus pi over 4, which is 3 pi over 4. And my other theta, notice I don't use commas, I say it twice, equals pi over 4 past 4 pi over 4 is 5 pi over 4. And we can answer the question like that like we did in the past, and we can check our answer, and we can type those back in and make sure they're equal to negative 1 over root 2, or whatever that equals as a decimal, like negative 0.707. But we also want to give what's called the general solution. And we remember that the theta gen is equal to our answers plus the period. Now what's the period? Well, we're working on cosine, so the period is 2 pi. So plus 2 pi n, comma, n-e-i. And our other theta gen, because we have 2, is our other angle, 5 pi over 4, plus our period, again, that we just calculated, NEI. So 2 types of ways that we can answer questions. As you can see in the question, it says solve for theta between 0 and 2 pi. In the first example on the page, sine theta equals 1/2, and we just gave 2 answers between 0 and 2 pi. Now they're saying between 0 and theta and 2 pi, which are the 2 answers, but then also the general solution. They may ask you just for 0 to 2 pi. They may ask you just the general solution. Be very careful. They may ask you for both. All right. Okay, let's take a look at a very similar question. Sine theta is equal to 0.8. So what does that mean? Well, I know sine's positive, so I'm going to draw 2 triangles where sine's positive. And so many times people get stuck and they go, yeah, I understand ASTC, but then they get to a question like this and they get stuck because it looks different. Well, sine's positive, so I'm going to draw 2 triangles where sine's positive, and I'm not going to do anything else until I've done that. Now, 0.8, well, 0.8 is a bunch of things. It's equal to 0.8 over 1, and it's also equal to 8 over 10. And in the notes, you can see I've drawn 2 triangles off to the right with both of those examples. But I'd rather be lazy and just label the opposite 0.8 and the hypotenuse just 1. Just makes more sense. Now we want to solve for theta. Well, I know that if sine theta is equal to 0.8, remember that theta is equal to the sine inverse of that, and we always do the positive. Even if it is positive, I mark positive to remind me. Now theta is therefore equal to 0.93 in radian measure. Remember, you have to be in radian measure. Check your mode, be in radians. I've seen too many people mess that up. And if we inverse the positive, that always gives us the reference angle, 0.93 or 0.93 if you like. Then we always put our arrows in and figure out what those arrows are worth. So the first theta in the first quadrant is 0.93. And if I were to sine 0.93, I better get 0.8. Make sure you check your answer, as I've done in the notes. Now my other, I'm going to mark 0 and I'm going to mark pi, but this time I'm going to change pi to be 3.14. Because if I want the second arrow, I have to do theta equals 3.14 minus that, as seen in the notes, for 2.21. And those are our 2 answers between 0 and 2 pi. And keep in mind In the notes, we've done the general solution, those two answers, plus 2 pi n, comma, nei. And that is the difference. So sometimes we're going to have an equation where sine is equal to a special triangle, where we need special triangles, but sometimes we get a decimal that's not a special triangle, and we have to use the inverse calculation. So all on our methods and formula sheets and checklists, make sure we know how to use which one. Okay, same page of notes, but just at the bottom this time. So we're going to go for the point -4, comma 3. So I'm just going to draw my graph perfectly so I just end up at that location. And I'm going to sway it a little bit just to save space on the page. So -1, 2, 3, 4, up 1, 2, 3, and that is our point already labeled above, and I'm going to draw my triangle. Now, I know my side lengths. Well, my horizontal adjacent is just my x distance, and my positive is just my y distance. Keep in mind, lots of teachers actually put negatives in those locations. I like to label diagrams according to positive amounts, and I like to let A, S, T, C determine the rest. So a little bit different page layout. I did some stuff off to the right. I'm just going to do it down below. So let's say what sine theta is equal to, what cosine theta is equal to, what tan theta is equal to, and choshikao, what cosecant theta is equal to, what secant theta is equal to, and what cotan theta is equal to. Well, sine theta is opposite over hypotenuse, so I need to find the hypotenuse. So I have to do Pythagoras' theorem. I'm just going to write it down. A squared plus b squared equals c squared, but we should be familiar with using that. And it's just the 3, 4, 5 triangle. I'm going to circle that information because it's found. So my sine ratio, I'm in the S quadrant. Sine is positive, and cos and tan are negative. I do that first. Cosecant is like sine, it's positive. Secant is like cosine, it's minus. Tan is like cotan, it's also minus. Sine is opposite 3 over hypotenuse 5. Off to the right, cosecant is just the flip of that. Cosine is adjacent over hypotenuse. Off to the right, secant is just the flip of that. Tan is adjacent TOA opposite is opposite over adjacent. And off to the right, cotan is just the flip of that. So how do we find that angle? Well, let's find it using tangent. So I'm going to use tangent right here because it's perfectly in order. And I'm going to say theta equals tan -1, open bracket, what? Well, we learned last time we always inverse the positive, even if the fraction is negative. And that always gives us the reference angle. So if we do that on the calculator, we get theta to be equal 0.644. And that is my reference angle. So I'm going to put it inside the triangle where it belongs. 0.644. Then I'm going to put my arrow from the principal axis to the terminal arm. I'm going to mark 0, and I'm going to mark pi, and I'm going to change it to be 3.14. And then I'm going to simply get my answer, theta, STP, by taking 3.14 and minusing 0.644 as seen in the notes, and I get my answer of 2.50. So they're going to ask for theta in standard position, the arrow, and they're going to ask for what we call the 6 basic trigonometric identities. And doing it in that fashion is going to be very, very helpful. All right, more on to these new definitions. So let's say secant of pi over 6 equals what? Well, I'm going to draw an ASTC graph. And I'm going to mark 0. Excuse me, it's a little bit off. And I'm going to mark 0, and I'm going to mark pi. I'm going to change pi to be a denominator that I'm working with, and times the top by that 2. And where does pi over 6 fall? Well, it's here for what we've done over the past many sets of notes. And then I'm going to label that triangle based on the definition. So I know a few things. I know secant theta is equal to the reciprocal of cosine. So it's hypotenuse over adjacent. So when I label my special triangle, if I draw my special triangle over here all by itself, lots of the times that's helpful. Pi over 6 is 30. 30 opens up to the 1. We have a hypotenuse of 2 and an adjacent of root 3. So I'm going to label that off to the left. Sometimes it's easier to put stuff off to the right and then bring it back into the question. So the secant of pi over 6, well, what is that? Well, I just wrote down the definition. It's just the hypotenuse over the adjacent. First of all, I'm going to ASTC my graph, and they're all positive in that location, so I'm going to say positive. And then I'm just going to label, based on the definition, what the hypotenuse is over what the adjacent is. And that is my answer. So not much difference from sine, cos, and tan, other than the fact that we're just using a different definition secant. Make sure that you check your answer in your graphing calculator. So remember, you press 1 divided by cosine of that. I'm going to use that all the time because I'd rather use that. It works every single time rather than use specific examples like secant of pi over 6 is 1 over cos of pi over 6. Secant of 2 is 1 over cos of 2. I'd rather just remember secant that is 1 over cos that. And again, take a look at the notes as seen from the formula sheets before. Secant of pi over 6 is absolutely not. Secant of pi over 6 is absolutely not cosine of 6 over pi. We don't flip angles, we flip ratios. Do not do this. It's wrong. This is the definition of secant. Okay, let's take a look at one more example from this page. Let's go for cotan of 5 pi over 3. So cotan of 5 pi over 3. This is in the example in the notes at the bottom right-hand corner. So again, I'm going to draw an ASTC graph, and I'm going to mark a STC. And now I'm going to wonder what cotan of 5 pi over 3 is. So I know that the definition of cotan theta is equal to 1 over, it's equal to 1 over tan theta, which is a good definition, but we're going to use the other definition. We know it's the flip of tangent. So tan is TOA, opposite over adjacent, so cotan is adjacent over opposite. So we need to find that. So we need to find 5 pi over 3 first. So we're going to mark 0, and we're going to mark pi, and we're going to change pi to be the denominator that we're working with. And I'm going to do monkey symbols again. So 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, which is in the bottom right-hand quadrant. And if I mark 2 pi and I do 2 pi minus 5 pi over 3, which would be 6 pi over 3 minus 5 pi over 3 for a reference angle of pi over 3. Again, get comfortable. And from our special triangles, let's draw that one off to the right in the same orientation. So if I have, that's not in the same orientation. If I draw it in the same orientation with pi over 3, well, that's 60. And 60 opens up to the root 3. It has a hypotenuse of 2 and an adjacent of 1. And we can bring that information back in. Therefore, using the definition in right, circled in big red, cotan is just adjacent over opposite. Well, we're in the C quadrant and only cosine is positive, therefore its reciprocal secant would also be positive, but cotan is like tan, and tan is negative in that quadrant. And the adjacent is simply 1, and the opposite is simply root 3. And there is my answer, negative 1 over root 3. If you want to check that on the graphing calculator, you have to press for cotan of 5 pi over 3. You have to do 1 divided by tan of 5 pi over 3. Make sure that you get a decimal, and then test negative 1 over root 3 as a decimal and make sure that's it. Okay, cosecant CSC theta is equal to 2. Well, what does that mean? C CSC theta is equal to hypotenuse over opposite, the flip of what sine is equal to. So if cosecant is equal to the hypotenuse over opposite, and I know that sine theta is equal to the opposite over hypotenuse, well, if my 2 in the question is over 1, I know that I have a hypotenuse of 2 and an opposite of 1 from our definitions. Therefore, sine theta would just equal the flip of that. And we did this question earlier on a few pages ago. You would draw an ASTC graph. Feel free to read the notes. Put 2 triangles where sine's positive, ASTC, special triangles, arrows, check your answer, etc. So I'm not going to do all those steps. Just flip the appropriate fraction and call it its new appropriate definition and do the question based on that. In the notes, we have off to the right in a double square, we have cotan theta is equal to 0.1. Well, what does that mean? Well, that's a fraction. Cotan theta is equal to 1 over 10. And I know that cotan and tan flip, so that is just tan theta equals 10 over 1. And I'm not going to do that question. You would draw an ASTC graph. You would put 2 triangles where tan's positive. You would either use special triangles or the inverse calculation to figure out what theta is. What if we have bottom left? Secant theta is equal to 2 over root 3. Well, I know secant is the flip of cosine, so cosine theta would equal root 3 over 2. And then I would just do this question. I would draw an ASTC graph. I would put 2 triangles where cosine's positive. If it was negative, it would be negative. And I would put 2 triangles where cosine was negative, but it's positive. Then I may also give a general solution. But if I ever get these odd trig identities like cosecant, secant, or cotan, I'm just going to flip them appropriately, stay positive or negative appropriately based on the primary trig identities like sine, cos, and tan. It's just going to make our life a lot easier. So in the future, in the notes, if you see dot, 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 or dot, 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 or dot, 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 it means that we have already done these procedures. You already have perfect notes and video on these procedures. We cannot continue to go over them each time. The notes in the video would take too long.